Okay, so in the last video, we looked at the definition of a logarithm and we looked at several properties for logarithms. In this video, we're going to look at one special log, and then we're going to look at one more property that we'll need based off of what calculator you have, because different calculators will solve these problems in different ways. First off, when we started with exponentials, we said there were a whole lot of exponentials with pretty much any base you want. But as far as it goes, there's one that's really important. Y equals e to the x. That's the exponential function. It's really, really important. It occurs a lot in the real world with lots of applications. Things like continuously compounded interest. But now we're talking about logarithms, which are the inverses of exponentials. And logically speaking, if exponentials have inverses, and this is the exponential that matters the most, then logically its inverse should also be a logarithm that's really, really important. And as it turns out, it is. It's what's called the natural log. And all it is log base e of x. That's the base for the exponential. So that's the base for my logarithm right here. And by definition, just so you can see it, log base e of x equals y. Definition from last time says that's e to the y equals x. And there's my exponential base e right there. The point to this, if we remember our exponential e, yes, it's a special log, and yes, we'll use it to solve problems, but all the properties hold the same. For exponentials, all the properties of e to the x were the exact same as any exponential, whether it's 2 to the x or 5 to the x. Same idea here. This is a special log. We call it the natural log because it's log base e, but it still uses all the same properties and still follows all of them from our last video. So don't think somehow everything changes just because we have this special thing. The one thing, though, to keep in mind, especially if you're looking at your calculator, log base e of x is written ln of x. That's just a shorthand way of writing natural log. If that is confusing to you, you'll see it on your calculator. It says ln of x. If it's confusing, anytime you see ln of x, you can just write log base e of x, and all your properties will hold. When I'm writing it, I'll generally write ln of x, because that's how you're going to see it in your book and on your calculator. We will come back to that when we get to problem solving, because much like the exponential e, it occurs a lot in real world problems, and it's useful algebraically to solve a lot of problems. One other thing we need, and I mentioned your calculator, and I don't know what type of calculators you guys are using on your homework, whether you're using a computer, because some of you send me computer printouts for some of your homework, or if you're just using a calculator, and if you're using a calculator, which type you're using, which one your high school gives you, if you have one on your own. Some calculators nowadays, if you want to solve the problem like log base 5 of 7, well, if we want to solve that, if we use the definition, log base 5 of 7 equals x, by definition means 5 to the x equals 7. If we remember from our exponentials, we can try to write those in the same base, but that's not going to happen. You can't write 7 in base 5, so we're not going to be able to write these in the same base. So what do? And as far as it goes, some calculators nowadays can solve problems in any base, which means you can just plug in log base 5 of 7, hit enter on your calculator, and get the answer, and you're done. If your calculator can't do that, and again, I don't know what calculators you're using, so I'm going to teach you this. If your calculator can do this, you can skip the next few minutes of this video because you don't need it. But if your calculator can't do logs in any base, then you're going to have to use a trick called the change of base formula. And it's actually a simple formula. All it says is log base a of x is equal to log x over log a. Basically, if you have a log with any base, you can rewrite it as log x all over log of the base right there, and these right here can be written in any base you want. Here I wrote log x log a, the common log, because your calculator can do common log, log base 10. But you could just as easily do ln x all over ln a. A lot of times that's actually what I use personally because I prefer natural logs. That's on your calculator too. But the change of base formula works for any base. If for some reason you wanted, you could change it to log base 7 of x all over log base 7 of a. That doesn't really help you because you can't put it in your calculator. But the point is, the change of base formula lets you change a log to any base you want. So if your calculator only does base 10 and base e, change to that base. So for this one, log base 5 of 7, that's log 7 over log 5. Or you could do ln 7 over ln 5. If you want to convince yourself that the formula actually works, find log 7 over log 5, then find ln 7 over ln 5. If the change of base formula is correct, those have to be equal. So plug them into your calculator to convince yourself, and they'll be equal. But again, that only applies if your calculator can't do logs in different bases. If it can, well then don't even worry about it, you don't need it. Just use the calculator button for different logs. But as far as it goes now, we have all these properties. We have rules for exponentials, we have properties for logs. We use a definition. We have log of product is sum of logs, log of quotient is difference of logs. If you have the log of something raised to a power, you can bring the power down in front. And we have the change of base formula. Now you want to at least set up and start solving basic problems. And as far as it goes, the one good thing about logarithmic and exponential equations is all of the problems are solved by using the properties. So you can essentially write down all the properties and just run down the list. Try property 1. If it doesn't work, go to property 2. If it doesn't work, go to property 3. All of them are solved by using the properties. Sometimes you have to do more algebra, but generally speaking, apply the properties. And then maybe apply some algebra that you learned earlier in the semester. So as an example, suppose we have log x plus log 2 equals 1. Solve that. Well, as far as it goes, what's the problem? Here the problem is I'm solving for x. X is inside of a log. So how do you bring something outside of a log? The only properties we have that do that are either the definition, log base a of x equals y, means a to the y equals x. That would bring the x outside of the log. Or we have that property, log base a of x equals log base a of y, means x equals y, if you can set two logs equal. The problem here is, well, I have multiple logs and they're not set equal to each other, so I can't really apply either property. So what do? Well, I do have a property that says the sum of two logs can be rewritten as log of the product. So I can join these together and get log of x times 2, which is 2x, equals 1. Well, now what do? I want to bring the x outside the log. Now I have the log equals a number. Now I can use a definition. What's the definition say? Log base, this is common log, so base 10, of that equals 1 means 10 to the 1 equals 2x. 10 to the 1 is just 10. So 10 equals 2x, divide by 2 on both sides, x equals 5. And I'm good to go. The last thing I will say as far as this goes, if you remember earlier in the semester when we were solving radical equations and rational equations, you occasionally get what's called extraneous solutions. The same thing can happen with logs when you're solving them. So always check your work to make sure your solution actually works. As far as it goes, you do not need to plug in 5 and then do all the math out to make sure you get 1. If your algebra is correct, the 5 will work. The only problem is sometimes you will get x's that are not in your domain. So all you're really checking for is to make sure it's in your domain. And we remember, I mentioned the graph before, and I said I'd use it over and over. The graph looks like this, which means the domain is everything greater than 0. So just make sure when you plug in your x, you're taking the log of something greater than 0. In this case, if I plug in 5, I get log of 5. 5 is greater than 0, so I'm good. So this will work, and that solution is fine. And again, I mentioned this before when we talked about extraneous solutions. It is not x being negative that causes a problem. It's if, when you plug that x into the log, whatever is inside the log becomes negative. What I mean, x equals 5 is a solution to this, but for the sake of argument, suppose this was log of negative x. Well then, if x equals 5 was a solution, when I plugged it in, I would get log of negative 5. That doesn't work because it's a log of a negative, so this wouldn't be a solution. So just keep in mind, you're not saying x has to be positive down here. You're saying when you take your x and plug it in, you end up taking the log of something that is positive. Okay. That should be all the properties we need and the setup for basic problem solving. Tomorrow I'll make another video or two where we actually solve several logarithmic and exponential equations and problems.